everyone, and welcome to our Year 9 chemistry session on this Sunday morning run by Elite Medics. So my name is Deborah, I'm a fourth year medical student, and I will be taking you through our session today. So this session in May is going to be a bit different because we know you guys are coming up to exams, and so we want to make sure that you guys are in the best state possible to sit those exams and do well in them. So today will be a revision session, okay? So I'm going to take you through the outline of today, what to expect, and then we will start going over the content that you guys will vote for. So first things first, this is our outline of the day. All the timings will run the same as we usually do. It's just that this will be dedicated to revision. So 10 to 12:30 will be our revision time with breaks in the middle, followed by a 12:30 to 1:15 lunch time. And then we'll have a final 45-minute revision session and we will end at 2 today, okay? So don't get bogged down by the times. I'll let you guys know when everything is happening. And since I said this is a revision session, I'm sure you guys have probably heard that word 2, 3, 4, 5 times already. Because we know that we've covered quite a lot of content over these months, really, this session, we're going to be focusing on the content that we have covered since January, okay? So this will especially be January to March. So we have a Slido interaction where you guys are able to vote for the topics that you want to cover the most. Don't expect to go through every single topic today, but if there are burning topics that you want to go over, please vote them up. Or if it doesn't win, then please put your questions in the Q&A, because I'm sure since it is a revision session, you will have a lot of questions. So please put that in the Slido Q&A section, and we will aim to answer as many as we can. Really, I think the main focus, other than, you know, the 3 main topics that we'll be covering today, is that I really want to get through your Slido Q&A. So really, I think the aim is to make sure that any kinds of misconceptions about chemistry in general that you might have, or any topics you want to go over, we want to really address those today. All right. So this is our outline of the day. And these are the 3 main topics that we will be going over. Okay. So it'll be metals and non-metals, the Earth's atmosphere, and the Earth's resources. So especially the last 2, these can be questions that will, it's very rare that you'll find maybe like a 1-marker question on Earth's resources or something. These are normally the slightly bulkier questions where they test, you know, the quality of written communication, etc. But if you do have a structure for those kinds of questions, then it will be okay. So don't worry too much about that. So in particular, in these 3 topics, we are going to be addressing these main areas. So in non-metals and metals, we have, of course, their properties, etc. Then we'll be going over oxidation with reactivity and displacement. Then in the Earth's atmosphere, we have that and the changes in the Earth's atmosphere from, you know, early Earth to now. And you also have greenhouse gases and global warming. And then finally, we have the Earth's resources, potable water, wastewater management, and alternative methods of metal extraction. Okay, so these, So these are our main topics that we can potentially go over today. So what I want you guys to do, we'll have our Slido on the next slide. I want you guys to vote for the 3 topics that we want to cover the most. So you should have the option to pick 3 each, okay? So if you guys scan the QR code on the left-hand side of your screen, or go onto slido.com and type in our login details 742731. If you haven't been here on this session before, you know that we will have access to all of the questions that we will be asking throughout our session today, okay? So I'll give you guys a couple of minutes to do so, just so you guys are able to log in and then also start voting, okay? And also well done to you guys for even tuning in on a Sunday morning. Honestly, the dedication you guys have, you should be proud of yourselves. I must say, this also does give me the opportunity to see how many have joined us this morning. So good morning to you guys that are logging in right now. Okay, I'll give you guys a couple more minutes. So far, it seems that alternative methods of metal extraction is in the lead. I mean, fair enough. In that section, we'll also be going over a bit of electrolysis. So it would be nice to get a bit of a refresher on that topic as well. Okay. Cool. So we'll stop there for now. Thank you guys so much for voting, and welcome to all of you guys that have been able to tune in. So it seems that our top 3 topics for now are alternative methods of metal extraction, reactivity and displacement, and oxidation. So if we do have additional time, hopefully we'll be able to go over potable water as well. But these 3 topics that you guys have voted for will be our priority, as well as our Q&A section. All right. Thank you guys so much. So now what I'm going to do, I'm going to scroll down to alternative methods of metal extraction, and we will start there. This is reverse osmosis. Wastewater management. Okay. There we are. Nice. All right. So let's get stuck in. So by popular demand, we'll first go over alternative methods of metal extraction. Okay. So let's just paint the picture before we start talking about extracting metals. So in general, when we get metals to use in products, etc., we normally get these things from metal ores, okay? And these are essentially naturally occurring metallic compounds that exist in the earth, okay? These are limited. And especially what we're going to do is that we're going to focus on how they extract copper, okay? Because this is something that is quite easy to understand, also because since copper ores are becoming scarce, there's a lot of research into different ways on how to extract copper. All right. So what we are going to be focusing on, we'll be focusing on phyto mining and bio leaching. Okay. So the reason why we're focusing on these new ways of extracting copper, because traditionally they used to use things like mining methods such as when you build a large quarry and you're essentially kind of digging down to get these metallic ores, all right? And this quarrying method would mean that you'd be digging loads, moving loads, and disposing of loads of rock, right? And in communities where they might be rich in metal ores, this would actually be really disruptive to the landscape. And this would mean actually that things regarding food, regarding growing food in the area, and things also regarding how they would be able to live their lives would become severely affected, which is why a lot of companies especially are moving away from traditional quarrying methods like this. All right. So, quiz question, because this is how these things work. All right. So, what I want you guys to do, type in a username that you guys want to be known by for the rest of our session, and it will be put on our leaderboard. And what I like to do, especially because it's a revision session, we want to be testing your active recall. So we want to be testing how much you know about the content before we cover it, all right? So that it will give you a good idea of where you are and what topics you need to cover. So if you guys have not joined our wonderful quiz sections before, the way you get points is number one, getting the answer correct, okay? Because this is a revision session, I'll make sure that our quiz timings are a bit longer so that you guys actually have time to consider your options and try and get your answers correct. All right. Then the next way that you can also move up the leaderboard is answering quickly. All right. But because this is a revision session, I will weigh that less. Really, what I want you guys to be doing is trying to get the answers correct as best as possible. All right. So I'll give you guys a couple more minutes just so you can type in your usernames, and then we will get this show on the road. Okay, I'll give you guys one more minute. All right. Okay, it seems like the numbers have slowly stalled, so it seems like a lot of you guys have already logged on, which is great. So, question will come up in 3, 2, 1. Boom. Okay. What is the name of the process that uses plants to extract metals from an ore? Is it bioleaching, is it photosynthesis, or is it phytomining? What do we call this process? Okay, I like this. Your answers are coming in fast. Well done. Seems like a lot of us are confident in what we call this process, which is good. All right, 30 more seconds. Okay, 15. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Oh, we were almost there getting all of you guys to answer, but let's see what you guys have said. Right. So we have a toss-up between phyto mining and bio-leaching. 70% of you said phyto mining, 29% said bio-leaching. So the 70% of you are correct. Well done. Okay. So the process that uses plants to extract these metals from an ore is called phyto mining. Okay. The way that I like to remember is that phyto sounds like photo, i.e. photosynthesis. So I know that this has something to do with plants and extracting that, okay? So let's explain this process. So essentially what will happen is that plants themselves, they do absorb metal compounds. They can absorb metal compounds from the soil, okay? Very small amounts, because of course you're not going to have a massive metal chunk that is just chilling inside of a plant, okay? So they absorb these metal compounds in small amounts, and what will happen is that these plants will be harvested, okay? They'll be taken out, and then they will be burned, all right? And then from the ashes, we will see the metal compounds that have come from it, okay? So really, I mean, from the plant's perspective, this is quite a brutal process, right? To be harvested and then burned, and then, you know, you have your metal compounds used. But this is something that people are looking more towards, because then you can get smaller amounts of copper and really extract the metal compounds from the earth that big processes like mining and quarrying just don't do. All right. So an advantage of this phyto mining is that you are able to extract even smaller amounts of metal compounds from the earth. All right. But the problem with this is, of course, you are burning plants. Okay. Plants, of course, will be taking in CO2 from the atmosphere and pumping out oxygen, right? So if you're going to burn a plant, you're going to release the CO2 that it's taken in, and you're going to burn that back out. Also, the whole process of burning, you guys know, combustion produces carbon dioxide and water vapor, all right? So you know that this process is also going to release carbon dioxide as well. So these are the disadvantages that you have for phyto mining, as well as the advantages. So well done, folks. Now, next question, because we are moving on to bio-leaching. All right. So question up in 3, 2, 1. Which of these is a disadvantage of bio-leaching? It produces sulfuric acid as a byproduct, it produces carbon dioxide as a byproduct, or it leaves large holes in the ground. So which of these is a disadvantage of bio-leaching? All right. So we've covered the disadvantages of phyto mining. So now what do we think a disadvantage is of bio-leaching? I'll give you guys a bit of time for that. All right, nice. Nice to see these answers coming through. 15 more seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, let's see what you guys have said. Oh, okay. So 59% say they produce sulfuric acid as a byproduct, 37% say carbon dioxide, which is correct. Sulfuric acid, well done to you folks that voted for that at home, okay? So what I'm going to do on the next slide, explain what bioleaching is, and then we'll go through our pros and cons like we did for our last slide. So well done, you guys are killing it. So what bioleaching is, is essentially it uses bacteria, okay, to produce these leachate solutions that contain metal compounds, right? So essentially, certain bacteria can break down low-grade ores, all right? So this is an example. Oh, my pen's not on. Right. So here is an example of a low-grade ore. When we're talking about low-grade ores, all we mean is that it doesn't have as much metal in it, okay? Low-grade ore, low metal concentrations, okay? So it just doesn't contain that much metal, which is why we want to use these kinds of processes to try and extract as much metal as we can, right? So these bacteria, right, they can break down these low-grade ores and they will produce an acidic solution, okay? So this leachate solution is acidic, right? Oh, you know, let me hold on to my screen, makes it easier. Okay, this solution is acidic. Okay, and contains copper compounds, all right? Because we're using copper for our example today. Right. So remember, bioleaching, you use bacteria to break down low-grade ores to produce a leachate solution, all right? And this leachate solution is acidic and it contains metal compounds, all right? So this is essentially the process of bioleaching. Bio, bacteria, okay, bio, all things life and living, etc. So that's how I like to remember it, okay? Bioleaching, bacteria, alliteration, right? And these will produce your leachate solutions. So when these solutions are produced, let me just rub that out, your metal compounds will be processed and you'll be able to take out that metal, all right? So a pro that we have of this method is, of course, because it's an alternative method of metal extraction, you can get copper, you can get more copper from low-grade ores, all right? i.e. ores that don't have as much metal inside of them, all right? So it's a good way of doing that. Also, this process does not need high temperatures, okay? So a pro of this, so it does not need high temperatures. Why? Because we're dealing with bacteria and they do not necessarily like high temperatures. So you don't need to you don't need to pump in more energy to get their optimal conditions, all right? They're fine with working at middle to low grade temperatures. Now, the problem that you guys rightly identified, okay, so our con, which I'll just do in thing, is that it produces sulfuric acid, okay, as well as other toxic compounds when it does this. And so the problem with this is that by producing sulfuric acid, it can actually also damage the environment, which is why they like to do bioleaching in controlled environments. All right. So to conclude, we've talked about phytomining, photosynthesis. We know that that is plants. So we know that with phytomining, you use plants to extract the metal from the soil, and then you will burn these plants and you will extract the metal compounds from the ashes. And then we also have bioleaching, where you use bacteria to extract metal compounds from low-grade ores by them producing a leachate solution, okay? And this leachate solution, again, is acidic and contains copper, okay? Right. Pros and cons of both of them. First, with phytomining, the pro is that you're able to extract small amounts of copper from soils that you wouldn't normally be able to, okay? So it's very high yield, okay? And also it reduces your need to obtain ores from, your traditional mining methods, right? If you're able to extract metal using a plant, you don't need to then go and use your traditional quarrying method, which involves destroying the landscape and really trying to find those high grade ores, i.e. those ores that contain a lot of metal in them, right? But the problem with phyto mining is that, of course, you are burning these plants to get your copper compounds. So this is something that will increase the amount of carbon dioxide in our atmosphere. Bioleaching. Now, pros is that it doesn't need to be done at high temperatures, and they can extract metals from low-grade compounds, so you're really getting as much metal as you can. The problem is that it produces sulfuric acid, so it's going to damage your environment, right? So these are our pros and our cons that we just need to know about. Nice. So now what we're going to do is that we are going to move on to electrolysis. So this is going to be a nice little recap for us. So copper can also be obtained from solutions of copper compounds, and we can do this via displacement, okay? The way we do this via displacement is that we can use scrap iron, okay, or we can use electrolysis. Now, I'm going to hold fire on this displacement reaction for now because I know that's something that you guys want to cover. So we won't talk about that for now, but we will still talk about electrolysis. Now, I'm sure that you guys in your chemistry sessions have seen electrolysis before. This is typically how it's set up. We have our negative electrode and we have our positive electrode. They are connected up to an electricity source, okay? And the whole aim of electrolysis is to essentially separate or remove compounds using electricity, all right? Electricity, lysis is to break up, all right? That's what we're using electrolysis for. So I have a couple of questions about electrolysis lined up, quiz questions, guys. Fingers on buzzers in 3, 2, 1. So electrolysis will not work when the compound is in a solid state. Why? Okay. Is it because ions are free to move? Is it because ions are not free to move? Is it because ions are arranged in rows, or is it because ions are not present? Okay. So why will electrolysis not work when the compound is in a solid state? So why will this not work when it is in a solid state? Okay, 30 more seconds, guys. Okay, 15 more seconds. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, so why will electrolysis not work when the compound is in a solid state? And this is because 90% of you smashed it. Yes, the ions are not free to move, okay? So we've established on our previous slide, electrolysis is essentially the breakdown of substances using electricity, all right? For that to work, these ions in our substances need to be able to move, okay? If they are free to move, they are free to go to whatever electrode that they are attracted to, all right? And this is how electrolysis works. If in a solid state, they're not free to move, electrolysis cannot do anything. So well done, folks. Next question in 3, 2, 1. What is the advantage of using carbon rather than electrolysis to extract a metal from its ore? Does it make a purer product? Is it cheaper? Is it better for the environment? What do we think? So what is the advantage of using carbon rather than electrolysis to extract a metal from its ore? Now, when we're talking about alternative methods of metal extraction, these kinds of questions where you're weighing up the pros and the cons can happen so often. So it's nice to have more practice with these kinds of questions, all right? 15 more seconds. Okay. 5, 4, 3, 2, 1, 0. Let's see what you guys have said. What's an advantage of using carbon rather than electrolysis to extract a metal from its ore? So 66% of you said it is cheaper, and you are correct, okay? So we'll actually touch a bit more on using carbon compared to electrolysis to extract metals, okay? Because when we're talking about our reactivity series and displacement, this is an important question, and this is how you can use your reactivity series to figure out what can be extracted by what, okay? But in general, as a rule of thumb, when we look at our reactivity series later on in our session today, the metals that are below carbon, all right, they can be extracted from their ore using carbon, all right? So let me take a step back. On your reactivity series, if you guys have one nearby, or if you guys have seen one before, they'll have a list of metals, of course, with the most reactive at the top, least reactive at the bottom. In italics, or maybe written slightly differently, you'll have a couple of reference non-metals. So you'll have carbon and you'll have hydrogen, all right? They might be like in italics, or they might be like in a slightly different font or whatever. So these are reference points to help you, all right? So really, when we're looking at our reference point, focusing on carbon, this is the cutoff point for when we are figuring out how to extract metals from their ores, all right? So on our reactivity series, the metals that are below carbon, all right, because they're less reactive than carbon, carbon can be used to help extract that metal from its ore, all right? If the metal is more reactive than carbon, so if it is above carbon on our reactivity series, this means that you have to use something like electrolysis to help extract the metal from its ore. All right, so that's just a brief explanation of how you can use a reactivity series to figure out what method to use. And we'll cover that a bit more later when we talk about our reactivity series. But in general, carbon is a cheaper method of extracting metal from its ore. Why? Because carbon is all around us and is very abundant and it's really easy to get a hold of. So it is a cheaper product, all right? But of course, when you're using carbon, sometimes it's not as good for the environment, right? So this can be a disadvantage. Also, comparing carbon to electrolysis, electrolysis is more likely to give you a purer product because you're really breaking down substances at the ionic level. So really every ion that you want to extract is more likely to be extracted when you use electrolysis rather than carbon extraction, right? But overall, carbon is a cheaper method of extracting metals compared to electrolysis. Now, next question. I add this question because it's something that we do need to know. So what is the physical state of the electrolyte when we extract aluminium? Okay, this is slightly different. This is aluminium, all right? Do we have an aqueous solution? Do we have a molten liquid? Or do we have a solid? So what is the physical state of the electrolyte in the extraction of aluminium? Okay, 30 more seconds, guys. Okay, 15 more seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, let's see what you guys have said. All right. So 62% of you said molten liquid, 32% said aqueous solution. All right. So this is just something that we will need to learn because they like to test on how they extract aluminium, and it's certain things like this, like that you need to know about. All right. So when you're extracting aluminium, all right, one word that you guys might have heard of is cryolite. Okay, so really, when you're extracting aluminium from an ore, we have all agreed that the ions need to be able to be free to move so that electrolysis can happen. All right, the ions need to be able to move when you are doing electrolysis. Therefore, your substance can either be in an aqueous solution, as we saw previously, or can be in a molten liquid. So both of these methods allow your ions to move freely so that electrolysis can take place. In particular, aluminium is a special one that we need to know about. So aluminium ores are melted, okay? They are melted into this substance of molten cryolite, all right? So just a special keyword there, molten cryolite. So CRYOLITE, cryolite. And this is a way to help aluminium ions to be free to move so that electrolysis can take place, right? So this is the main example that we need to know of when electrolysis of when your electrolyte needs to be in a molten state compared to an aqueous state, right? So well done, folks. All right. So we have another quiz question because I did want to kind of test as much as I could in this session, all right? So an ore of zinc contains zinc carbonate, all right? So the equation for this reaction when zinc carbonate is heated is zinc carbonate produces zinc oxide plus carbon dioxide, all right? So we've seen this reaction, zinc carbonate makes zinc oxide and carbon dioxide. So my quiz question to you guys is this. What is the name of this type of reaction? What do we call this type of reaction? So I add this question in because you guys need to be able to identify what reactions are taking place. Okay, 30 more seconds, guys. What do we like to call this type of reaction? Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, let's see what you guys have called this type of reaction. Nice. So 77% of you said decomposition, and you are correct, okay? So the reaction that we saw there with zinc carbonate forming zinc oxide and carbon dioxide is an example of thermal decomposition, all right? And that is typically how they are set up, right? So we don't necessarily class thermal decomposition as a type of chemical reaction because you're not really reacting two chemicals together. But remember, if you see one product, especially a carbonate, decompose into an oxide and carbon dioxide, this is more than likely an example of a decomposition reaction. Okay, you guys know this as a thermal decomposition. All right, so well done, folks, for getting that correct. Now, let us go on to our quick recap of electrolysis as I've been doing verbally. Let's see it on screen. So you guys know electrolysis is the breakdown of substances, i.e. the electrolyte, using electricity, okay? So this part is more expensive because you do need a lot of energy charged into it because, you know, you do need electricity for this process to happen, especially on a large scale. And you guys have nicely identified that your electrolyte, okay, so that substance that you're trying to break down, they need to be ionic compounds, right? And in order to get those ions to freely move, you can either have it in its molten state, like aluminium, or you can have it in its aqueous state, which a lot of metals use. We'll just use the example of copper, right? So now we've done our recap of electrolysis. Now I'm going to ask you specific questions about extracting copper from copper sulfate. All right, so we're going to do the electrolysis of copper sulfate to get pure copper, right? So that's what these quiz questions are going to go over. So fingers on buzzers, guys. Now, in the electrolysis of copper, which electrode will pure copper accumulate? Is it the positive electrode? Is it the negative electrode? Is it the neutral electrode? Or is it neither? Where do we think pure copper will accumulate? Okay, 30 more seconds, guys. So to figure this kind of question out, you have to figure out what is the charge of a copper ion. That is the only hint I will give you. What is the charge of a copper ion? Okay. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, let's see what you guys have said. Okay, so 59% said the negative electrode, 33 said the positive. What is our correct answer? It is the negative electrode. Well done, folks. You guys are smashing it. All right, so to figure this out, I gave you a hint where you need to figure out what the charge of a copper ion is. All right, typically a copper ion is positively charged, right? So when we're thinking about all of our ionic compounds, especially the ones that include metals, right? So maybe your wow, I've gone completely blank. So we have copper sulfate, zinc chloride, zinc carbonate, all of these kinds of things. Typically, the metal in these compounds will be positively charged, all right? And we know when we're talking about electrolysis, we want to extract those positively charged ions. And the way that we do this is that opposites will attract. So your positive ion will be attracted to your negative electrode, all right? So that's how 59% of you got to that answer. Well done. Now, next question, we're looking at what we see physically, all right? So as the electrolysis of copper sulfate occurs, the blue color of the solution, what will happen to that? Will it darken? Will it become green? Will it turn white? Or will it become lighter? So as the electrolysis of copper sulfate occurs, what will happen to the blue color of the solution? This is also a really important question to consider because chemistry is not only about the theoretical processes behind what happens, it's also about what you can see as well. And a lot of students, they get to the theoretical side, but when it comes to the physical side, that's when things can get a bit patchy. So this is why I wanted to include this question so that you guys are able to experience both and you can see where you need to improve. So 30 more seconds, guys. What will happen to the blue color of the solution during electrolysis? Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's see what you guys have said. Right. So this one's a bit more split, but we will tell you guys how to approach this. So our correct answer is this. So 37% of you got that correct. Well done. Okay. So in the electrolysis of copper sulfate, we first have to figure out what makes that solution blue, right? Because we know it has a nice blue color, but what's actually causing that blue color? What is causing the blue color of the solution is the presence of those copper ions, all right? Whenever you see copper sulfate, the reason why it is blue is because the copper ions are free to move about, all right? So I think in particular, it is copper 2+ ions that make this solution blue. So in electrolysis, we know that we are trying to extract those copper ions from our electrolyte, aka our aqueous solution, right? So the more copper ions we extract, the less blue our solution will be, all right? Therefore, our solution will become lighter, i.e. will eventually become clear because we have less and less copper ions in our solution, all right? So that's how we got to that answer. So well done, 37% of you. So the reason why it doesn't become green is because there are no ions in our solution that would turn this green, all right? Typically, iron compounds, so you know, iron compounds, they can turn a solution green, all right? Typically. There's a particular kind of ion that turns that solution green, but because we have no ions in this solution, it won't be green, okay? So remember, when you have blue, think copper. When you have green, think iron, right? So these two are not related whatsoever. Nice. So well done, folks. And this so far is our leaderboard. So Bazinga is currently in the lead, followed by JM, then OJ, then Jazzy, and then AG. So well done to all of you guys that are getting those questions correct at home as well. And thank you also to those guys that are still trying their hardest.